we have seen that all the induced or excess charges distribute over the surface of conductor, and there is no charge on the surface of cavity, and no electric field inside the cavity. But now, let us place a charge inside the cavity. If we consider a Gaussian surface like this, then as the field in the body of the conductor has to be zero, so the flux through the surface will be zero, and thus net charge enclosed by this surface should be zero. This implies that an equal and opposite charge should be induced on the surface of cavity. This induced charge balances the field created by this charge, so that the net field in the body of conductor is zero. However, inside the cavity, if we draw a Gaussian surface like this, then as there is a net charge enclosed by this surface, so the flux, and thus the field inside the cavity, will not be zero. But note that net field inside the cavity will not be due to this charge alone, as the induced charges are non-uniform, so the field due to these induced charges will not be zero inside the cavity. Thus, net field inside the cavity will be due to the induced charges, as well as this charge. Now, when some charge is induced on the surface of cavity, then from the conservation of charge, there must be an equal and opposite, unbalanced charge left in the conductor. What happens to this charge? Well, the induced charge on the cavity has balanced the field due to this charge. So these charges do not experience any field. This charge is not even aware if there is any charge or cavity inside the conductor, and this charge cannot stay in the body of conductor, because in that case, field in this region will not be zero. So this is like an excess charge placed on the conductor, which will repel each other and come to the surface of conductor. This charge distributes itself such that it does not produce any field inside the conductor. So the induced charge on the surface of cavity is such that it balances the field due to this charge. Charge on the surface of conductor is not aware of the cavity and charge inside it. So even if we remove this part, this distribution will not change. So if we move the charge inside the cavity, charge distribution on the surface of cavity quickly changes to cancel the field in the body of conductor. Charge on the surface is not affected by this. Charge distribution on the surface is affected only by the external field. So if we bring a charge near this conductor, charge distribution on the surface will quickly change to cancel the external field. So external field does not affect the charge distribution on the surface of cavity. It affects only the charge distribution on the surface of conductor. So the system of cavity is not aware of the charge distribution on the surface of conductor. Charge on the surface of conductor is distributed such that the field inside the conductor is zero. This means that the conductor divides the space into two independent regions, which do not interfere with each other.